Many people begin a project assuming research is synonymous with gathering information, but standard methodology texts distinguish genuine research from the simple movement of information. You can collect 100 citations, organize them perfectly, and summarize what other scholars said, but you haven't actually conducted research. You have only performed transference. The essence of research requires an active interpretation of that data. You have to look at the collected facts and draw an explicit conclusion to resolve a specific problem. Without that interpretive leap, a paper is merely clerical work, not an original contribution to knowledge. Formal research functions as a way of thinking, a controlled, empirical, and rigorous habit of questioning what we observe. Raw data has no inherent meaning until it passes through a methodological core. That structure is what turns scattered observations into interpreted knowledge. To understand how this works in practice, we must examine 3 pillars: the taxonomy of different research types, the operational process step by step, and the boundaries ensuring strict focus. Methodology is the scaffolding that separates professional scientific inquiry from amateur observation. We can classify any research project along 3 intersecting axes: its application, its objectives, and its inquiry process. Let's look at this through the lens of a cybersecurity problem, like ransomware detection. The application axis divides pure research from applied research. Developing a new mathematical proof for cryptography is pure research. It builds foundational, theoretical knowledge. Testing a specific software tool to see if it successfully quarantines ransomware on an active server is applied research. Next is the objectives axis. This determines whether your study is descriptive, correlational, explanatory, or exploratory. A descriptive study paints a picture of a situation. In our scenario, this means auditing a network to determine the exact number of unpatched vulnerabilities. An explanatory study goes deeper to answer why. Why did a specific zero-day exploit manage to bypass the existing firewall? Finally, the inquiry process determines how data is handled. A quantitative or structured approach measures variables in numerical terms. A qualitative or unstructured approach explores the diversity of a phenomenon through open-ended observation. This document highlights an approach called competitive benchmarking, a specific applied research method. In fields like information systems, you also have technological research, where you develop software artifacts to prove that a theoretical architecture functions in reality. Selecting the precise methodological tool dictates the credibility and strength of your final results. Once you understand the taxonomy, you map the work using an 8-step model, from formulating the problem to the final report. Everything hinges on step 1. The axiom garbage in, garbage out applies perfectly. If the initial statement is vague, the methodology collapses. To prevent this, you must inspect your primary problem and subdivide it into highly specific, manageable subproblems or testable hypotheses. Asking, "How do we stop ransomware?" is a weak, unusable research question. A rigorous problem formulation would ask, does implementing machine learning behavior analysis increase detection rates of encryption-based ransomware compared to signature-based scanning? Only after locking down that exact question can you move to step 2, the research design. This is where you explicitly lay out the mechanics of extracting answers from your data. That design bridges the planning phase and the execution phase, allowing you to begin collecting, processing, and displaying empirical data. The quality of your final report depends entirely on the precision you applied when formulating the initial problem. A precise problem statement naturally leads to the necessity of boundaries. You have to eliminate any possibility of misunderstanding by clearly defining the limits of your research. This involves establishing your delimitations, or scope. This is a perimeter fully controlled by the researcher to keep the study manageable. You must also outline limitations. These are structural constraints that restrict your study, like sample size or computational power, which are outside your control. Scoping your project means explicitly stating you are only analyzing Windows ransomware, entirely excluding Linux variants. Fully disclosing these boundaries up front allows audiences to judge the credibility of your final results. Bounding your inquiry is a technical requirement, but it is also tied directly to intellectual integrity. Any rigorous study must strictly adhere to ethical approvals and informed consent when handling test subjects. This document outlines the standards set by the Committee on Publication Ethics, or COPE, which establishes the international baseline for scientific conduct. According to these guidelines, acts like plagiarizing, falsifying results, or failing to declare conflicts of interest are catastrophic methodological failures. When done correctly and ethically, research is a cyclical, helical process. The resolution of one specific problem inevitably reveals the emergence of entirely new problems. Formal methodology provides the rigor needed to transform collected facts into a verifiable contribution to knowledge.